So before we get started, I want to briefly introduce our speakers. We have Daniel, who has a bachelor's in bioinformatics and genome research, a master's in genome-based systems biology, and a PhD in genomics and transcriptomics. And since 2015, he's the de.NBI training coordinator, and since 2016, he's also training coordinator for Elixir Germany. And we have Helena joining us, also with a bachelor in bioinformatics and genome research and a master's in molecular cell biology, finishing her PhD in plant biochemistry and physiology. And she is part of the Elixir Germany Administration Office since 2021 and is the training platform coordinator and deputy training coordinator. And with that, I'm going to hand over to the two of them and yeah, take it away.
Today, we will talk about 1001 reasons for data management plans. So as introduced by Julia, this is a short version of our between 3 and 5 hour workshop. And we try to summarize our workshop as good as possible for the webinar format. First of all, I want to introduce our network, so the German Network for Bioinformatics Infrastructure. The name includes the typical terms. So we are the German Network for Bioinformatics Infrastructure. We represent a German research infrastructure for life sciences. So we cover different disciplines from medicine to chem informatics to almost everything. And our mission is to provide bioinformatic tools and services, resources, training for life science researchers in Europe and in Germany, of course, to improve and help them during their data analysis. And our network is divided in so-called service centers. So we have 8 different service centers that represent almost all typical disciplines in bioinformatics, from human bioinformatics, microbial bioinformatics, plant bioinformatics. So these are typical organism-based bioinformatic service centers, but we have also RNA bioinformatics and proteomics for different molecules. And we have a service center that is more involved in workflows, the integrative bioinformatics service center. We have large databases in our portfolio that belong to the so-called biodata node. And last but not least, we have a service center for data management and systems biology. In total, we have in Germany 42 different partners. And as you see on the card, they are spread all over Germany. If you want to come in contact with us, there are several possibilities. So we have the webpage de.NBI. We are available on Twitter and LinkedIn. And you also find us on YouTube, for example. We have a newsletter, so there are different possibilities to come in contact with us. Now to Helena.
Thank you. Hi, everyone, and thank you for the introduction. So we can directly start with my part of this course, which will include some general aspects about data management. So in this workshop or in this webinar, we will present some general basics about data management and data management plans. And we also will present why data management and the data management plans are so important for your research. We will talk about the data life cycle and the FAIR principles, and we will also present some helpful tips for a good documentation. So, thank you. First of all, let's find a description for scientific data and metadata and what the difference is between these. So next slide, please. Scientific data are all digital data used or generated in the research process. So this could be raw and processed data, simulation data, observational data, but also code, algorithms, and scripts, and also audiovisual data. And the scientific data is shown here, for example, as a box. And what is metadata? This is a structured data containing information about characteristics of other data. So, for example, who did this data or who generated the data, when, why, and how. It gives information about resources that are used and also about abbreviation, units, and names. and also includes information about licenses. The question is, how can you manage these sets of data in a proper way, and what is data management, how it is defined? So a general definition is data management describes the totality of all measures in dealing with research data. So this is an all-encompassing definition, and the measures mentioned here include different steps or processes, namely the creation, processing, and documentation of the data, but also the saving, publishing, and archiving of the data. And all these steps are involved and integrated in the data lifecycle, which is shown here. And the data lifecycle describes the different stages of the data management. We will discuss it in detail later. So why is data management so important? And what are the benefits of doing it? Here, the keywords indicate the importance of data management. So research data management has a general goal of making data accessible, reusable, and verifiable, long-term and independent of specific individuals. Accessible, reusable, and verifiable, these are the keywords I mentioned, and good data management, what follows the rules and the structure of the life cycles, also fulfill the main aspects of the FAIR principles. And these FAIR principles represent the key components of good data management. Now let's have a look about these FAIR principles. What are the FAIR principles about? The principle stands for findable, accessible, interoperable, and reusable, and they must be fulfilled when dealing with sustainably reusable research data for human and also for machine, for example, the computer, and the principles that should be also taken into account when setting up services or research data infrastructures. So the first principle is the findability. This means that the data or also the metadata should be easy to find for human and the computer or the machine. This means that machine readable metadata is essential for the automatic findability, and this can be reached by global, unique, and persistent identifiers, for example. So here are some links provided with examples of globally unique persistent IDs, and also some links for identifier and, for example, the DOI. The second principle is accessibility. This means that you provide access to your data without a special or proprietary tool. And this also means that the protocols should be free, so no costs, open sourced, and globally implementable. For example, HTTP would be such a format. And this also means that authorization and/or authentication may be required, for example, for sensitive or for personal data. The next principle is the interoperable principle. This principle describes the interaction or also the integration of different data sets or different data metadata with applications and workflows for your analysis, the storage, and also the processing. And the metadata includes qualified references to other metadata. It should be readable for computers. This means you use commonly used vocabulary, ontologies, and thesaurus, and you also have a good data model, for example, clearly defined framework for describing and structuring the metadata. The last principle is about the reusability of the data. So you can ensure reusability of your data if you use detailed description of your data and metadata. For example, in which context were the data generated. You should also include experimental protocols, for example, an electronic black book. Then you should also add the information, what are the special features or limitations of the data, under what circumstances, who did this, parameter settings, for example, on the software you used, name and version of software you used. It also includes the raw data, in some cases, and also the processed data. And the variable names should be explained or should be self-explanatory. And you also should add link data to licenses. So for example, under what conditions this data can be reused by others. I mentioned before that these FAIR principles are not a rule, but they are principles. So they haven't a strict rule, but they give you some guidance in managing your data and your project. And by applying your FAIR principles, you can be sure to have a high quality of your data. So the problem is when you have sensitive data, you have to take special care of it. So open science does not, or FAIR principles does not automatically mean that everyone can have or use your data. So you can give restricted access, for example, only for defined persons or for a special institute or something like that. And in this case, you can follow always the guideline that your data should be as open as possible and as closed as necessary. So we would like to show you a short video. Maybe you already know this, but this video describes very well the problems that many researchers are dealing with when it comes to FAIR practice in their project.
On B cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah yes, SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is, and SAM3, and SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Yeah, maybe you have experience, also made same experience like the fair bear. So here are a few statements we just heard. I'm not sure where my data is, that, for example, USB stick is my only copy. You will need the program that created the hexadecimal file, and everything you need to know is in the article. So the problems described here are the following. First of all, there's no ID. It is not indexed. You have no defined access protocol, and your only copy is on a USB stick or somewhere at home. And there's no standard format, and you also have no metadata or no further information about the data, and there are also no licenses described. To avoid such problems in your project, some helpful RDM or data management strategies could be help. So for example, always to have at least one backup of your data. Another helpful strategy could be publish your data in a storage repository with a unique ID and also with defined access. Describe the data format and the use program. Give detailed description of your data and also metadata, insert metadata at least, and define the responsibilities for the project. Who is the contact person for this project?
In the first slides, you heard lots of the typical basics about data management things, and I would say this is the base to go here more in detail into the data management life cycle. I would say it's divided into 3 parts, and we will go deeper into the first part, into the planning part. So that's the before implementation part. Here, all needed steps for further action, for further processing are described, including also financial, legal, and ethical aspect. And therefore, we're talking about data management plans, because these aspects will be then mentioned in the data management plan. Then there's the active project phase. So in that phase, you start with the identification of existing data for your project. You need to think about the storage and backup of your own data. You need also to think about how to organize your own data. What is, for example, the naming scheme for your data? Of course, documentation is an important aspect, because if the corresponding person that analyzes the data, that goes more in detail into the data, is gone, you need some kind of documentation, you need metadata to reproduce these kind of results in the end. And of course, security and access is an important aspect, especially when you think about sensitive data, for example, medical data. And the last point here is the post-productive phase, where you have to think about, also the aspect of reproducibility. You want to normally publish your data somewhere in a paper. For that, in most of the cases, you need to upload your data in a repository, or you have to have your data available somehow, somewhere. You need to think about a good license for your data. Not every license is suitable for every kind of data. As mentioned, metadata is important, because if someone wants to reproduce experiments or wants to reproduce something, metadata is very, very important. Of course, legal aspects are always important, and yeah, archiving is, I would say, included here at several points, for example, at the repositories. Yeah, now I want to talk more about data management plans. So the first time when we had a summer school on data management in 2017 in Braunschweig, we had lots of people there from Germany talking about their problems of writing a data management plan, because they started in different EU projects. And as you see here, the EU is normally forcing or fostering data management plans. So in the Horizon 2020 environment, you have a DMP as requirement. You need to provide the first plan in the first 6 months, and a specific template is available. And that will be also mentioned on the next slides. You need to update this several times if significant changes happened, and of course also in the end of the project. And that's a very, very important guidelines for DMP. So DMP, I would say in lots of the cases, you will hear that the DMP is a living document and you need to update it several times during a project. So in Germany, it's not that fixed. So the DFG wants to have only specific information how your scientific data will be handled. And at the BMBF, it depends on your project. So if you have a very data intensive project, then a DMP is required. But also here, most of the cases, no DMP is needed. But in future, more and more DMPs, also the DFG and BMBF will force. So now I want to talk about what is a DMP, what does a DMP include, and how a DMP is structured. In our normal program, we also talk about how does my work fit into a DMP. There we will have I would say, an interactive session where we describe how to write a DMP, and we also discuss then their different examples for DMP text, but that's a little bit too time consuming for this webinar today here. So as mentioned before, a DMP is a living document. It is continuously updated, and it represents an entire project overview, and all kind of data handling is included, and it also includes somehow the short and long-term view, how your data will be handled in short-term and long-term. It is important for aspects like collecting, organizing, and processing data. And it should include in Germany, it's the wie, wo, wer, warum. In English, it's why, how, and where. So these are the important questions that should be answered in a DMP. What are the requirements and the benefits of a DMP? So the normal requirements, as mentioned before, some funding agencies want to have a DMP before, but a DMP also belongs to a good scientific practice. And in lots of different institutes, it belongs also to the guidelines, to the researchers, that the DMP is somehow the good scientific practice. And of course, legalization. Benefits. Okay, the first point is always a discussing point, because it saves on the first view no time, because it takes some time to define a DMP and to update the DMP. But thinking about longer time, it saves time and also resources, due to the aspect that you plan something before. It also improves the data security and also you will have less loss of data and of knowledge about the data. Reproducibility of the corresponding experiments is a very important aspect. And for example, when you think about sharing data and cooperations with other institutes or other partners, it improves also the usability, the reusability of data. And of course, the overall goal, as mentioned before, is reproducibility of your own data for others. The most important aspects that a DMP should include are mentioned here. So it should include information about data collection and documentation, storage and backup should be defined, data sharing should be mentioned, responsibilities, resources, security, ethical requirements, and last but not least, the costs should be defined. Under collection documentation, you need to think about aspects like, is there already existing data that belongs to my research project? And if so, what is the nature of the data? What kind of formats? What's the scope of the data? And of course, how is the data generated with machines, with versions of software? These are here important informations. Of course, quality and the quality control is a very important aspect. Fulfills my data a certain quality control or not? As mentioned before, the documentation of metadata is important. Therefore, which kind of metadata is essential for my data, that it should be reproducible in the end, and what kind of standards and methods will be used to create my data. As mentioned in the video, storage and backup are also very important aspects. So to have just one backup is normally very problematic. So you should think about how will my data will be stored during the project and also after the project. That's also important. Archiving of the metadata and data is important. You should know where your documentation is stored. And of course, you need to think about the informations. Yeah, as also mentioned in the video, when you have different abbreviations like SAM1, SAM2, you need to know what's behind these abbreviations. And also here formats, IDs, and not that common definitions should be stored somewhere. And of course, the most important aspect of data is if it's somewhere gone due to an incident, you need to know how to recover the data. When you think about sensitive data, of course, how is access and security managed and during and after the project. In case of data selection, you need to think about especially the long-term aspect. So the typical questions are here: what data have long-term value and should be shared and stored for a longer time? And of course, also the time frame is important. So during most of the projects, if the data is stored not in a public repository, you have normally the minimum of 10 years, but especially when you save your data in an open repository, this makes also long-term preservation much more easier. That is, I would say, also a typical plan here for long-term preservation. Yeah, data sharing is also important when you think about corporations, when you are in a project and data should be shared between different project partners. Of course, here also the long-term value is important, and also the why is it important. So not every data is maybe important to should be stored a longer time. So when you think about an Excel sheet or something like that, that it is just temporary use, then it's not that important for long-term storing. of course, aspects like why will the data shared and is also important. And yeah, you need to also think about certain difficulties in sharing data. So are there maybe secure transfer ways are needed and this kind of things. Yeah. Last but not least, copyright and intellectual property rights need to be handled, and that's, I would say, a common problem when you think about, for example, sharing presentations. You have always pictures, and you need to take care of the corresponding license that are used there. Yeah, especially for storing data and for backupping data, you need to think about the responsibilities and resources. So do you have a large backup system at your institute, at home, or is it maybe an open repository the best way? Maybe it is important to have an additional training for this kind of backup things, because you need to think about several aspects. And yeah, you need to always think about several aspects, not only the data itself, but also the documentation and also the storage of the metadata are also here important aspects that need to be remembered. So, and also security and ethical requirements need to be in a DMP. Here you need to think about managing the data access and the security. This is in most of the cases aligned with personal data and identity protection. So you need to think about how especially this kind of data need to be protected. Also, ethical issues need to be handled and need to be planned in the DMP. And I would say for me, one important aspect is, of course, the choose of the correct license that need to be selected for your specific data and also for data reusability in the end. And last but not least, data management costs money. So you need to think about which resources are needed. So on the one hand, maybe you need someone who's responsible for managing your data, so a data manager or data steward, positions that maybe are needed in your institute or are needed here for the project, so they cost money. And of course, you need to think about, is additional hardware, software, technical support by someone from your university, or is specific training needed? So this should be also included in your DMP. So if you need to know more about DMPs and additional resources in the data management field, there are several websites, several tools, several wikis available on the market. So for example, we worked for the RDM kit that we will also present in the next workshop here together with GHGA. And there are several good resources. And if you are not sure about how to handle your data, just check one of the addresses, and they are also quite helpful for data management plans and data management. So in the end, I want to thank you for your attention, and we are open for questions. Thank you.